section 12.1 is on trigonometry functions in right triangles. Trigonometry is the study of the relationships between the angles and the sides of a right triangle. And if you'll remember, we did a little bit of this, kind of the basics, in geometry last year. Trigonometric ratios are fractions that compare the lengths of the sides. So given right triangle ABC, we use the Greek letter theta, which looks like a zero or a circle with a line through it, to represent the measure of the angle. And in this case, theta is the measure of angle A. And remember, the hypotenuse of a right triangle is always the longest side, and it's the side that's directly opposite the right angle. So in this triangle, in relation to theta, side BC is opposite because it's directly across from that angle, and side AC is the adjacent because it's right next to the angle. Now you might be saying AB is also right next to angle theta, but the hypotenuse is always the hypotenuse. It can never be the adjacent side. So here are your 6 trig functions. You'll probably remember sine, cosine, and tangent from geometry, but we also have cosecant, abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. Now you probably also remember from geometry that we talked about SOHCAHTOA, that sine, I'll go ahead and write it over here. Oops. There we go. That sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. So which is what I have written right here. The sine of angle theta is the length of the side opposite theta divided by the hypotenuse. Cosine of angle theta is the length of the adjacent side divided by the hypotenuse. Tangent of theta is the length of the side opposite divided by the length of the side adjacent. Cosecant theta is defined as hypotenuse over opposite. Notice that that's just sine theta flipped. So cosecant of theta is like the inverse of sine theta. Secant is defined as hypotenuse over adjacent, and notice that's just cosine flipped. And cotangent is adjacent over opposite, which is tangent flipped. So it might, I guess it would make sense if cosecant were actually cosine flipped, but it's not. So that's the one where you have to remember that it's not what seems obvious. So sine and cosecant are flips of each other, cosine and secant are flips of each other, and then tangent and cotangent are flips of each other. So here's an example. Given this triangle, we need to find the 6 trig functions for theta. So in other words, sine, cosine, tangent, secant, cosecant, and cotangent for theta. Now, a helpful thing to do when you're doing this is to label what the sides are in relation. So in relation to theta, 6 is the opposite, 9 is the adjacent, oops, and this one over here is the hypotenuse, and we don't know what that is. We're going to have to figure out what that is. So to do that, we're going to use the Pythagorean theorem. So 6 squared plus 9 squared equals, I'm just going to call it c squared. So 36 plus 81 equals c squared, which is 117, or c is equal to the square root of 117, which simplifies to 3 square root of 13. So I'm going to go ahead and add that to my diagram. So my hypotenuse is 3 square root of 13 units long. So now with all of that information, it's pretty simple. We're just going to plug those numbers into these ratios that we saw right here. So sine of theta is going to be opposite over hypotenuse. So 6 over 3 square root of 13. And I need to simplify that a little bit. I can start by doing some canceling here. That becomes a 2. But remember, I can't leave a radical in the denominator, so I'll multiply top and bottom by square root of 13. So sine of theta is 2 square root of 13 over 13. Cosine of theta is going to be adjacent over hypotenuse, or 9 over 3 square root of 13. Again, I can do a little simplifying here. That becomes a 3, and I have to rationalize my denominator. So the cosine of theta is 3 square root of 13 over 13. Tangent of theta is opposite over adjacent, or 6 over 9, which simplifies to 2/3. Okay. Now to find cosecant of theta. Okay. Remember, cosecant, let's look back at our chart here, is just sine flipped. So I'll go back to what I had for sine here, which was 6 over 3 square root of 13, which simplified to 2 over the square root of 13. So this is just going to be the square root of 13 over 2. And remember, it's okay to have a square root, or square root in the numerator. Secant of theta is just cosine flipped. So let's go back to what we had here. That's going to be the square root of 13 over 3. And cotangent of theta is just tangent flipped, or 3 over 2. Here's another example. In triangle ABC, angles A and B are acute. Find the remaining 5 trig values for angle A if the cosine of A is 3/10. So let's just go ahead and draw a triangle here, a right triangle. Doesn't have to be very accurate. Okay, so A and B are my acute angles. That means C is my right angle. And in relation to angle A, so if the cosine of A is 3 over 10, that's going to be the adjacent over the hypotenuse, because cosine is defined as adjacent over hypotenuse. So in relation to angle A, the adjacent is this one here, and the hypotenuse is this one here, which means I need to find what my opposite is. So again, I'll use the Pythagorean theorem. 3 squared plus, that's a leg, so that's not the hypotenuse. B squared equals 10 squared. 9 plus b squared equals 100. B squared equals 100 minus 9, or 91. Or b equals the square root of 91, which cannot be simplified. That's already simplified. So my other one here is going to be square root of 91. I'm going to go ahead and label those. Hypotenuse, adjacent, and that's my opposite. And I already have cosine of A, so let's find sine of A. Sine is opposite over hypotenuse. So that's going to be the square root of 91 over 10. Tangent of A is opposite over adjacent. Square root of 91 over 3. Cosecant of A is, remember, cosecant is just sine flipped, so I need to do 10 over the square root of 91. Rationalize my denominator, or 10 square root of 91 over 91. Doesn't look simplified, but believe it or not, it is. Secant of A is going to be cosine flipped, which is easy, that's 10/3. And cotangent of A is going to be tangent flipped, or 3 over the square root of 91. Again, rationalize your denominator, or 3 square root of 91 over 91. So the trick to doing these last two problems is, I think, is using the Pythagorean theorem to find the missing side, or the hypotenuse. And I think it's really helpful if you label, and if you need to in a different color, that might be helpful, your opposite, adjacent, and hypotenuse. It'll really help you when you go to fill in those values for the ratios. Okay, here's a couple problems that we did in, similar to the ones we did back in geometry. We're going to use a trig function to find the value of x and round it to the nearest tenth. So what you need to ask yourself, or actually one important thing you need to remember is a trig function, so sine, cosine, tangent, and those are going to be the three we use most often. A trig function is something you do to an angle. So I'm going to be using sine, cosine, or tangent of 64 degrees. Okay? But now the trick is to figure out which one I need to use. So I need to look at that angle, and in relation to the 64, x is opposite, and 4 is my hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So I'm going to take the sine of 64, and that's opposite over hypotenuse, or x over 4, and I have my basic equation. Now I just need to solve that. To do that, I'm going to multiply both sides by 4, because remember what I'm trying to do is find x. So x is equal to 4 times the sine of 64. And then just plug that into your calculator. Make sure that you are in degree mode and not radian mode, and round that to the nearest tenth, and you'll get 3.6. So the length of the side opposite the 64-degree angle is approximately 3.6 units. Number 2. So here I have a 48-degree angle, and in relation to that 48-degree angle, well, x is the hypotenuse, and 22 is adjacent. Opposite would be this side down here at the bottom that I don't know anything about. Okay, so the trig function that uses adjacent and hypotenuse is cosine. So I'm going to take the cosine of 48, and that's equal to the adjacent over the hypotenuse. Now this one's a little bit tricky because now in the previous problem I had x in the numerator, x was in the top of the fraction. Now I have x on the bottom of the fraction. So in order to solve this, I'm going to have to multiply both sides by x so that those x's on the right hand side will cancel. So I'll have x times the cosine of 48 is equal to 22. And now I want to divide both sides not by 48 but by the whole cosine of 48. So x is equal to 22 over cosine 48, and grab your calculator, punch that in. X is approximately equal to 32.9 units. Now sometimes you'll notice, actually let's go back, you'll notice these problems here, x was in the length of a side of a triangle. In this case it was one of the legs in number 1, and in number 2 it was the hypotenuse. Sometimes x can be in the angle. So if you don't know what the measure of the angle is, but you do know 2 of the sides of the right triangle, we're going to use an inverse trig function. So let me show you how to do that. So in relation to x, 15 is adjacent, and 17 is the hypotenuse. So the trig function that uses adjacent and hypotenuse is cosine. And remember I said you always take the sine, cosine, or tangent of an angle. So I'm going to take the cosine of x, and that's equal to adjacent over hypotenuse, or 15 over 17. Okay? So how do I do this? I can't punch cosine x into my calculator, so I need to do the inverse of that trig function, which means x is equal to the inverse cosine, and it looks like cosine to the -1, but remember a -1 really means the inverse. So the inverse cosine of 15 over 17. Basically this means what is the measure of the angle that has a cosine of 15 over 17. And you can do this in your calculator, so you hit second cosine and then 15 divided by 17, and you get that x is approximately equal to 28.1, and that's the degrees of that angle right there. So if you don't know the measure of the angle, you'll need to use the inverse of the trig function. Let's try another example. Here I have x is the angle at the top of this triangle. Oh, and actually I forgot, in this one, that is a right triangle. There we go. 27 in relation to x is the opposite. 18 is the adjacent. And the trig function that uses opposite and adjacent is tangent. So I'm going to say the tangent of x is equal to opposite over adjacent, 27 over 18. And you can reduce that if you want, since they're both divisible by 9, but it's not necessary. And next step would be to say that x is equal to the inverse tangent of 27 over 18. Or in other words, what angle has a tangent of 27 over 18? Plugging that into your calculator, x is approximately equal to 56.3. So remember, if you don't know what the angle is, you'll need to use the inverse of the trig function. Hit second in that trig function on your calculator and it'll take you right there.